First of all, I'm Jordi Roglans. I'm the director of the Nuclear Engineering Division here at the laboratory. And I think it's very exciting to be celebrating the 75th anniversary of CP-1, which was a remarkable scientific achievement that was conducted here 75 years ago. And among many other things, it gave rise to the creation of the laboratory, which celebrated 70 years last year. So anyway, this session will have the previous part of the session focused on international nuclear status and programs. And we are going to be talking now about domestic nuclear technology and the status of the nuclear energy in the US. We have three speakers that will be representing spectrum of the nuclear power industry in the US. So we'll have a representative from one of the large vendor companies, one of the original ones, the GE, now GE-Hitachi, and a representative from one of the early or the new startup companies, a very young company that developing very innovative reactors, Oklo, and finally a representative from the largest nuclear utility in the US, Exelon, that is operating 23 nuclear reactors right now, among them the ones in the state of Illinois, which is, I think, the state with the largest number of operating nuclear power plants in the US. So we will start with Eric Loewen, who will be our first speaker. He's the Chief Consulting Engineer for GE-Hitachi Nuclear Energy. Eric has spent 35 years in the field of nuclear science and technology. He started in the nuclear Navy. He then went to the Idaho National Laboratory. In 1999, he was part of the Generation 4 initiative, development of liquid metal reactors. I think he focused on the lead bismuth reactors at that time. He's been working on sodium reactors ever since, I think, in the GE-Hitachi. He spent also 10 years as director of the research for the molten metal technology in Fall River, Massachusetts. He was a fellow in the Congressional Fellow for the American Nuclear Society in 2005 in Washington, and then became president of the society in 2011, 2012. So he's going to give us, I think, what is going to be a very interesting perspective, a very interesting paper. The full paper will be posted on the website. He was insisting that he needed an hour for his presentation. I resisted that. I tried to keep it to 20 minutes, so he'll give us only an abbreviated presentation, but the full paper will be posted on the website. So Eric, please.
Sometimes we listen, sometimes we don't. But I always listen to everything that Warren Dyer had to say. Today, some of our nuclear community is assembled here to honor the CP-1 pioneers that realized the concept of extracting energy from the atom for the first time controlled by humans. Today, we recognize the drive of those bold pioneers. By our linkage to them, my remarks are compelled by the basis of business where we conceive, design, build, sell, operate, or use, and then repeat. But for Linda Young and the others here that are more physicists, and this isn't necessarily your area, I think a basis for the CP-1 team utilized when they conceived, designed, built, and operated CP-1 for the eventual use of the technology which humans could harness, the atom's energy. I invite your attention to one of those CP-1 pioneers whom I got to know, Warren Dyer. I'm going to tell you who he was, how I met him, and what I learned from Warren. And I will end by asking all of you here today three wins that were discussed many times by Warren and I. Warren was born in November 18th, 1921. Warren was an accomplished gymnast, skier, climbed the Tetons many times. Warren was one of the very few physicists who worked at all 5 of the Manhattan Project sites: Chicago, Oak Ridge, Hanford, Los Alamos, and the city south of the Trinity site. In the fall of 1941, he was a 19-year-old physics student at the University of Chicago when he was hired or drafted into the University of Chicago's physics department by Dr. Jesse with Dr. Compton's permission. In the physics department, he was a low-level workman. Warren's duties expanded to machining graphite blocks. His duties expanded again into the counting room where he monitored the counting apparatus that measured the neutron drift in the pile, which was located in the adjacent room. The scientists would discuss the project in the counting room adjacent to the pile, and Warren told his son several times, quote, "All I had to do to stay up on my research was to keep my mouth shut and my ears open." After CP-1, he worked on the X-10 reactor down in, I forget where that one's, Allen, down in Oak Ridge, Tennessee. Sorry, it slipped my mind there. And at Hanford, he measured the reactivity at the B reactor. Then at Los Alamos, he worked on the multiplication experiments of uranium and plutonium, the underpinnings of the nuclear reaction for an atomic bomb. At the Trinity site, he was a participant and the witness to the atomic test in July of 1945. After the war, Warren returned to Los Alamos in 1947, where he worked on the resonance absorption of uranium nucleus with 14 MeV neutrons. Preferring to work on the peaceful uses of the atomic energy, Warren moved his family to Idaho Falls just before Thanksgiving of 1951. There he headed the experimental physics group at the material test reactor, at then called the National Reactor Test Station, and now Dr. Peters, who's the director, calls it the Idaho National Laboratory. Good marketing. That's too many letters. In 1956, he ran the Special Power Excursion Reactor Test, or the slang is called SPURT, which consisted of 4 different reactor kinds. The reactors ran from 1955 to 1979. Then he became a member of the Atomic Safety and Licensing Board, and he finished his career as a management consultant to electric utilities. Warren started his nuclear career at the age of 19. He died February 4th, 2016, at the age of 94. He is the next to last living member of the group that worked with Enrico Fermi at the Chicago Pile. Laurel told me that Ted Petrie is the sole remaining CP-1 survivor today. How I met Warren Dyer. 15 years ago in 2002, Warren and I were among the attendees at the 60th anniversary of CP-1, held at Idaho State University. Strangely, he did not have a prominent role, nor did I recall him even speaking. As the luminaries of that time reflected on the momentous events of CP-1, after it was over, I hesitantly approached this legend of the nuclear history and introduced myself to him. And I sensed Warren was relieved that somebody came up and talked to him. His early comment during that conversation went along the lines of, "I hate these anniversaries. I get paraded out like a museum piece." Our friendship grew. Back in Idaho Falls, where we both lived at the time, I would pick Warren up for our local A&S meetings since he did not like driving after dark. After one of those Idaho A&S meetings, an INL intern, Hannah Yount, my wife, and I were invited for a nightcap in Warren's house. As we were leaving, Warren shared that we were the first people he entertained since the death of his wife, Henrietta, 2 years prior. At another local A&S meeting Warren and I attended, the speaker was Lieutenant Governor James Risch. He declared December 16, 2003 as Warren Nyer Day. The reason he could do that is because then Governor Dick Kempthorne had left the state, so he was the governor and he was empowered to make that day stick. After a very quiet marriage the next year to his second wife, Martha, my family was invited to dinner at their home, allowing me to meet one of his sons, Michael. Later, when I visited Idaho Falls in 2013, Warren declined my request to visit him, though we had been in contact for years by phone and emails and letters. He did arrange a lunch with his son, Michael, where Michael shared Warren's message to me, quote, "I am fully retired now." These were the last personal words that I received from Warren before his death in February of 2016. So what did Warren teach me? The Navy, mistakenly taught me that SCRAM was the acronym for Safety Control Rod Axeman. Thinking the Navy was right, I told this to Warren at Easter dinner. He smiled. Then he told me that what SCRAM really meant. He recalled the story this way. The head of instrumentation was a man named Vonley Wilson, or known as Bill Wilson, and his instrumentation group had 3 different tasks. One was by Randolph Crane, who oversaw the detection equipment. The other was Louis Sultan, oversaw the mechanical designs of the control rods and safety rods, and Bill Overbeck, who designed the circuits on the panel. Recently, I learned that Wilson and Crane were from GE's research laboratory from New York. They decided to have a big button that would push and drive in one set of safety rods. Late one afternoon, Overbeck asked, quote, "How should we label the big button?" Either Hugh Barton or Tom Brill asked, "What are we going to do after we push the button?" This is important. Bill Wilson of GE said, "Scram the hell out of here." Bill Overbeck said, "Okay," and wrote the word scram under the big button. Yes, there was Norm Hilberry, Fermi's deputy director, who at the first criticality experiment began on the morning of December 20th, 1942, held an axe to chop a rope to drop in another set of safety rods if there was a problem. Yes, there were 3 graduate students standing to break glass carboys of a solution of cadmium to put on the pile if something went wrong. They were later called the suicide squad. And on the second approach to criticality that afternoon, Warren shared that he replaced one of the members of the suicide squad so a suicide squad member could go up and replace Norm Hilberry as the axeman because Hilberry needed to be relieved so he could tend to the administrative tasks. Yes, the paperwork. I also learned from Warren that he shared a very unique distinction with his wife, Henrietta. They were one of 3 couples, probably in the entire world, that witnessed July 16th, 1945, the Trinity test. Warren, 10,000 yards south of Ground Zero. Henrietta on the ridge at Los Alamos because somebody whispered in her ear, "You should probably get up about 3 a.m. in the morning and look in this direction." Whenever Warren was asked what was the secret of the atomic bomb, he always answered the same. The secret to the atomic bomb is it can be done. After that, it's only a matter of determination. When Warren taught me about the spurt reactor projects, this particular reactor was run to destruction, the sentence I remember most was, "We could do anything we wanted to as long as we intended to." While sharing another meal with Warren, I asked him what books might he recommend that I should read to help my nuclear science and technology career. He looked at me and said only 2, The Peter Principle and Parkins Law. I pushed back and said, I was thinking of some technical books, and Morin responded, "I expect you to know the technical science. You asked me what books would help your career." I've read them both several times. I assign them to the young engineers that are in my stewardship. From the Peter Principle, I ascribe to the most common summation of this work: most people are promoted to their level of incompetence. Parkins Law, published in 1957, is a little bit different. It dispels the public visualization of elected officials or captains of industry or civil servants as trustworthy or proven leaders or technically competent as, quote, ludicrous. The book provides a glimpse of the reality of the simple laws. I will share 4 of them with you. First law is that work expands to fill the time available, thus staff organizations grow according to the formula that's on the slide. K is the number of staff seeking promotion by having more subordinates. L is the difference between the age of the appointment and their retirement. M is the amount of hours spent on email, translating to today's language. And N is the number of units or divisions or boxes that to be administrative. Therefore, X becomes the number of employees needed per year to be hired. He validated this law with the Royal Navy's, Fiona, with the Royal Navy's number of admirals to ships. And perhaps, Steve Binkley, on your org charts of AEC, we should revalidate it, and we should look at what we're doing now currently. Law number 2 on high finance is simple. In mathematical terms, the amount of time spent on a budget item is inversely proportional to its amount. As A&S treasurer, I validated this law with the board of directors. Law number 3, councils, committees, and forums follow the elementary principle of science that they are organic rather than mechanical in nature, and they are like plants that take root and grow and grow. And if they die, they scatter their seeds to bloom yet again. Warren challenged me when I was A&S president to question whether some of the committees were past their prime. And I know Bob is listening in the back that he will take that law into heart. And to show me that he was keeping up, in 2006 when we talked on the phone, he said, "Eric, what will the Generation International Forum accomplish?" Law number 4. This law addresses the principle of leadership selection and how to choose the right candidate from all those who present themselves. In the past, Paul and Fiona, the English used a system to determine who the candidate was related to, thus, in other words, who they knew. In the past, in China, during the Ming Dynasty, the Chinese used a competitive written examination, held every 3 years, for 3 days, and the person who held the highest marks typically was destined for the highest office. And in other words, what they knew. This later technique for leadership selection has been copied in many forms and works reasonably well. Warren shared with me he believed the nuclear regulatory commissioners and the DOE lab leadership are being selected via the political process with more of who they knew instead of, as in his day, what they knew. When people like David Lilienthal, Louis Strauss, Glenn Seaborg, and Dixie Lee Ray held leadership positions. And as an aside, I recommend you read Dixie Lee Ray's last book called Environmental Overkill, Whatever Happened to Common Sense, published 1 year before her death. So I see laws 3 and 4 about committees and leadership selection have combined in toxic ways throughout private and public sectors. In several places that I've seen, committees of peers select the leaders based more upon who they knew or where they were from rather than what they knew or could do for the organization. Committees can be paralyzing. If computers start to take over our lives as currently predicted, all we need to do is organize them in committees. When I was A&S president, I ran into a few delicate issues. Warren was always available by phone to listen to offer guidance. Why? Because Warren was one of the plank owners of A&S that started in 1954. He knew how it was built, and he knew where it was violating Parkins laws. So I urge each of you to discover that book. It's a great, easy read. Warren instilled into me that we in the nuclear science and technology community stand on some tall shoulders of those strong individuals who took complex tasks and got the job done. That allowed for the fastest rate of growth of a new energy source into the energy market. The spark, as Paul talked about it. The beacon, simple, or as Chung talked about it, that told the Koreans to go forward was the 1953 Eisenhower's Atom for Peace speech. But take Argonne scientist Samuel Untermeyer, who conceived of the BWR. So for those of you that don't know that acronym, it's the best water reactor, which led to Borax-3, the first reactor in the United States that sent electrons over a grid to power Arco, Idaho, July 17, 1955. Not to take away from the UK's Calder Hall reactor, Paul and Fiona, But may you have forgotten that just 43 miles, or 65 kilometers, from here, on April 15th, 1960, the first privately financed, full-scale nuclear power plant, best water reactor, went online at Dresden Nuclear Power Plant 1, putting 180 megawatts electric on the grid. And I will brief my remarks and not talk about the great things that the PWDRs did from Oak Ridge, Allen. Forgive me. The 3 wins. Warren and I regularly discuss the 3 nuclear wins regarding waste, national laboratories, and builds. We did this when I worked at Idaho National Lab, and we did it when I worked at GE. The first win is when will waste be put to rest? The Yucca Mountain Project was conceived over 30 years ago in the 1980s. In our profession, we deal with the unchanging laws of physics, gravity, pressure, temperature. Yet also in our technical careers, we might grapple with ever-changing public opinion, public policy, and the laws of government. The Yucca story validates Dixie Lee Ray's charge or obligation to all of us to provide factually based information that can be understood by policymakers and the public at large. Nevada, the public, the policymakers did not understand the benefits of this repository for the future of our society or of our technology progress. The task, which is endorsed by ANS policy statement, I think, Bob, you still have this policy statement, complete NRC's licensing of Yucca Mountain. Complete the process. When will our national laboratories deliver? So before I get taken off stage, my next sentence is as follows. Our nation needs its national laboratories. Our nation needs our national laboratories. These multi-program complexes attract world-class talent. They do neat things. We need you to be motivated to facilitate the transfer of laboratory expertise from these world-class user facilities that I stand today to commercialize the peaceful uses of the atom into the U.S. private sector. That's progress. That's simple. That is the value statement to the U.S. taxpayers. So my 3 humble suggestions to my colleagues at the national laboratories are: 1, get the gains gateway open wider. 2, focus on one mission, one issue, one area. And 3, get the Department of Energy, Ray, this is for you, get the Department of Energy into a simplified oversight model, back to Parkins Law, that seeks national outcomes of value to the U.S. public utilizing metrics of excellence and effectiveness. And finally, when will we build? Warren Dyer asked me at Idaho National Laboratory and when I worked at GE, when are we going to build an advanced reactor? That's not an alarm. Okay. So we have lost our sense of purpose and conviction of the pioneers who built, have we lost this conviction of the pioneers who built CP-1? NE just released a new mission statement, and I quote, "Advanced nuclear power as a resource capable of meeting the nation's energy, environmental, and national needs," end of quote. I like it. And I'd also like to see each of us that are American citizens, because this isn't your law, Fiona or Paul or Kang, affirm the goals of the Atomic Energy Act of 1954, which were make the maximum contribution to the general welfare, encourage the widespread participation in the development and utilization of atomic energy for peaceful purposes, make the benefits of peaceful applications of atomic energy available to the cooperating nations, and increase the standard of living. We need to focus our resources on one thing to build the next fission tool, our CP-1. The tool needs to either give us fast neutrons or a system that operates above 510 degrees C. We all know from Generation 4, from AFCI, from GIF, GNEP, the latest NEAC report, that we have 2 choices that are ready to go. 1, a sodium-cooled reactor system, or a high-temperature gas system. This build would, in keeping with the bills rumbling around in Congress of the versatile neutron source, this build could unite the laboratories with individual deliverables very similar to the spallation neutron source did at Oak Ridge National Laboratory. This build would establish a formal framework for working with U.S. industry and internationally. This build would provide this nation back on the international stage moving forward with a new fission tool. Simply put, build the next fusion tool now. It's our nuclear community's moral imperative to be strong with fission power. We must be stronger in our approach. The weak, be it an animal, an organization, a technology, does not survive. There's no middle ground between weak and strong. We need to be strong. So let us tip our hats to the moral strength of those pioneers of CP-1. Let us emulate those bold pioneers to build fission tools and fission power plants, but when? So I need help with the last 5 words of my remarks, which are on the screen. We'll do it on 3. But when? 1, 2, 3. Warren would say now. Let's try that again. On 3, 1, 2, 3. Warren would say now.